Thus far in this course, you obviously learned a lot about JavaScript. And we did dive into JavaScript in the context of the browser. In this module, we'll now have a look at a different environment where JavaScript code can be used, and that's Node.js, a JavaScript environment that allows us to run JavaScript outside of the browser. Now, really important to understand here is that what you learned thus far is of course not obsolete. It's the same language, the same syntax, the same keywords, functions are defined in the same way, variables are defined in the same way. The difference, of course, is that we won't have access to all these browser APIs, to the DOM and so on, but I will dive into that in more detail in this module. Well, to be precise, in this module, we'll have a look at what exactly Node.js is and how it differs from the browser as a JavaScript environment. We'll then, of course, learn how to write Node.js code, how to write basic Node.js scripts and applications, how to host a server with Node.js, but also how to do something totally different with Node.js. And we'll also explore Express.js, which is a framework for Node.js that makes building more complex Node.js applications, specifically web servers, much easier. Last but not least, we'll also have a look at how we can talk to a database and store data not just in memory of JavaScript and not in browser storage, which every user can see, but instead how to store data on a separate database server. That's what we'll have a look at in this module, and therefore let's not waste any time and dive right in. As you learned, JavaScript is a hosted language. That means JavaScript itself, the definition of the language, can be implemented in different environments. All you need in the end is a JavaScript engine that parses the code and executes it in the end. And one very common environment, of course, is the browser. Browsers have their own JavaScript engines, like the V8 engine in the case of Chrome, and this in the end hosts and executes the JavaScript code therefore. Now, together with the browser APIs you learned about, like the DOM or the browser storage or the fetch API and so on, you got tools to build rich client-side applications where you utilize the language and all its key features and keywords and so on, combined with the browser APIs to provide the user experience you want to provide. All of that then runs in the browser, so directly where your users are. But of course, nothing speaks against taking JavaScript and executing it somewhere else. We can do that, we can execute JavaScript anywhere else we want by simply taking the JavaScript engine and taking it out of the browser basically. And that's it. We can then add our own APIs if we want to, so not APIs to work with the DOM, for example, because if the JavaScript engine, if the environment is detached from the web page, there is no DOM, right? There is no HTML code which we could parse if we run JavaScript somewhere else. But instead, we might want to add new APIs, APIs which don't exist in the browser. For example, to work with the local file system, which is not possible in the browser due to security reasons. And that's exactly what Node.js does. Node.js is essentially the extracted V8 engine Chrome offers, enriched by extra APIs. So it's that engine you know from the browser, but basically instead of the browser APIs, it has access to other APIs and it runs outside of the browser. This is Node.js. And of course, this also implies that what you learned about JavaScript still is relevant. Just the browser-specific parts, like the DOM or the browser storage, of course, are not important when we work with JavaScript outside of the browser. So let's now have a look at Node.js. For that, you can simply open a brand new folder with nothing inside of it. Here I just got my IDE configuration file and the git config file. You need neither of the two. So you can create a brand new folder and open it in your editor, in Visual Studio Code here. And in there, we can add a script, app.js maybe. And now here we can write some code which does not depend on the browser APIs and execute it with Node.js. For example, to have a very simple script, we can add console log in here and say hello world. The console object and the log method on it is provided by the browser, but Node.js also offers this. So this is actually a functionality we can use both in browser side and in Node.js side JavaScript. It's not part of the core language, not part of the engine itself, but it is provided as an API, so to say, by both environments. Now, if we save that, the question is, how can we now execute that file if we don't load it into a browser, into an HTML file? And the answer is by using Node.js. You can visit nodejs.org, and you most likely already did this because we had to install Node.js already to use Webpack and so on. If you haven't done it, make sure you install the latest version of Node.js now, in my case 12.11, but of course that will most likely have changed by the point of time you're watching this. But simply download this latest version, download the installer you find there, and run through that installer to install Node.js. Once you did that, and Node.js is available for all operating systems, once you did that, you can run this app.js file with the help of Node.js. For that, simply open your terminal, for example here with View Terminal, or open it outside of the IDE and navigate into the folder you created with the cd command. And then you have a node command available now that you installed Node.js. You might need to restart your system to ensure that this works. Type node into the terminal and then the file name you want to execute, app.js. And this will tell Node.js, which was installed in your system, to run this JavaScript file. Basically the same the browser does with files it encounters in the HTML code. So if we hit enter here, you should see hello world as an output here because Node.js executed that file. And of course, if you would try to do something which Node.js doesn't understand, for example, use query selector and search for a button, if you execute this file, you would get an error. Here you see I'm getting an error, that document is not defined. That's what I mean with the missing browser APIs. But all the core JavaScript features exist. We can, for example, also create a new variable or constant with the const or let keyword, username, and name that Max, and change this here maybe to use a template literal, that's also supported here, so with these backticks, and say hi, username, like this. And if we now execute this file with node app.js, we see hi Max here. So that all works, and this is Node.js. It's JavaScript running outside of the browser. Now you can use Node.js for anything you want. You will often find it in the context of web servers, because indeed you can use Node.js as a server-side language. You can write a web server with it and write all the web server logic for handling incoming requests and for sending back responses. You can do all of that with Node.js, but you're not restricted to that. In the end, you can execute any JavaScript code you want here. And Node.js, for example, also gives you certain tools, which we'll have a look at, that allow you to write a file or to read a file. So that's also something you can do with Node.js. And you could therefore use Node.js to write your own utility scripts that do a task you want to perform on your system, that download your latest bank statements from a server and store that in files, or anything you want. You can write your own utility scripts with Node.js if you want to do that. You can write Node.js code that parses an Excel file and reads in the data. All of that is possible with Node.js, or especially if you then add third-party packages, which of course also exist for Node.js apps and not just for browser-side apps. But we don't even need to look at such more complex examples. If we have a look at the practice app we worked on in an earlier module, there we also use Node.js without even noticing it. The webpack config.js file is a JavaScript file. Now, who do you think is in the end using and executing this file? It's not the browser. We're not importing this into HTML. And for example, this here, this module exports thing, would also be something HTML doesn't understand or the browser doesn't understand. The same for these strange imports up there. This is Node.js syntax, and I'll dive into this in a second when we write our own script. But this is Node.js, and therefore in the end, what's executing this config.js file and what's taking this into account is a Node.js script. In the end, when we run npm run build or build dev, we use the webpack tool or the webpack dev server. And what happens there is, behind the scenes, Node.js is used there to execute certain JavaScript scripts which do not run in the browser, but which utilize Node.js methods to read your files, because Node.js is able to read the file system and parse files. So that's what Webpack does behind the scenes. It uses Node.js to read in your files. It uses Node.js to have a look at the Webpack config.js file and to then use this configuration. So Webpack runs on Node.js. It's written in JavaScript to work with your JavaScript code, but it uses Node.js because it, of course, does not run inside of a browser. We don't load Webpack in the browser. We load the finished result into our page here, not the Webpack script itself. So there we implicitly already use Node.js with the help of this Webpack tool. And therefore, back to our script here, let's now see what we can do with Node.js outside of a web server environment before we then later also have a look at how we can use Node.js to write our own simple web server, serve a page, and receive incoming requests. So this basic script here just outputs something in the console. Now, how about writing this data to a file and then reading the data in from a file? For that, we need a couple of packages which are available when you install Node.js. Node.js works such that certain very important features are available globally. For example, set timeout. This is a browser API that was also implemented in Node.js, and you can't just use it like this in any Node.js file. But other functionalities, which you don't need that often, need to be imported explicitly. For example, functionalities for working with the file system. For that, Node.js works with so-called modules. And on nodejs.org, you can learn more about that. In the docs there, if you click on API reference, you find all the packages, all the core modules Node.js is made up of. And for example, here under F, you find the file system module, and you find the complete documentation for this module. Now, as you can tell, there's a lot in there, and of course, we'll just briefly dive into this, but we will use it a bit at least. So there, for example, we see how we can make this module and its features available in a Node.js script. And that's one important difference to browser-side scripts. The Node.js import-export syntax looks a bit different. Instead of using the import and export keywords, in Node.js you use require to require a module, be that a module provided by Node.js, like in this example, or be that your own file. And then you store the required data in your own constant, which you can then use in your script. And I will later also show you how you export something. So with that, let's copy that and add this here in our app.js file. And this pulls in the file system module, which again was already installed as part of Node.js. So we don't need to install it separately, but we still need to add it to this file with this line. And now we can use the file system object here to work with the file system. For example, to call the write file method here, which takes a path to a file and then the data we want to write to that file. And there we could, as a simple starting point, just provide a file name, and then this will be written in the same path as the script sits in. For example, we could write this to user-data.txt, let's say, to write a text file. And then as a data, we could have some text here. Username equals Max, for example. You can also define some write options here as a third argument, where you can set things like the encoding and so on, but we don't need this here. We can just execute this file like this. Now, write file then takes a callback as a third argument, which potentially holds an error if it failed. And we can then check if we do have an error, in which case we could console log it, for example, and otherwise we know we succeeded, and we could console log wrote to file. And now with that, if we now execute our app.js file, you see wrote to file here, and you should have a new file being added here to your system where our data was written to. And this is how easy you can write a file with Node.js. Of course, you can also read in a file, so parse a file. You do this with the file system here, with read file, and then the path to the file, for example, with user-data.text. Then again, you can set some arguments or just provide your callback here. This is a callback function that takes two arguments. First argument is a potential error object, which will be undefined if we have no error. Second argument is the data we hopefully get. And then here we can check if we do have an error. And if we do have one, we can console log the error and then maybe return to not continue with the execution. And otherwise, we'll get our data. So let's see what we get there if we print this. And now if we save that and we run this script again, we see wrote to file, but we also see this buffer output here, which is coming from parsing the file. Now, of course, that buffer is not that useful. If we call toString on that, it gets more useful though. Now this is converted to a string and we got the content of the file being output there. So this is a very simple Node.js application, of course, if you want to call it like this. But we see some Node.js APIs in action here. And at the same time, we see regular JavaScript syntax like the if statement, which we use here, or the const keyword, which you, of course, learned about throughout this course. So we played around with Node.js a bit, and we saw one of its built-in core modules which you can pull in to add certain functionalities which are not available in the browser, but which are available in Node.js. One important difference compared to the browser, of course, is that some modules need to be imported with this syntax in order to use them, whilst others are available globally. And most modules actually need to be imported, by the way. In the browser, all the things by default are available globally. You can't just access document like this. You can't just access local storage like this. That's one difference. In Node.js, it's more of a you have to tell me what you need approach. Other than that, however, it's highly comparable. We have the same base language and then some specific APIs. Now let's move away from this dummy script here. I'll name it files.js and add a new app.js, which is empty. And let's see what we can do in Node.js when it comes to working with HTTP requests, because that arguably is an important scenario where you would look to Node.js, running a web server with it. So let's see how that would work. It all starts with a specific module you can require, and that's the HTTP module. It's a module that allows you to work with HTTP requests. This, by the way, does not just mean that you can listen to them. You can also create a request and send it to a server. But more commonly, you use Node.js to set up a server that listens to incoming requests so that you can have your own web server. And in the end, by the way, that's also what the Webpack dev server and all these other development servers do. They use Node.js to set up a basic web server which runs locally on your system to host your HTML files, your simple local web application. Now we'll basically do the same here, but we'll not just build our own development server, but instead we'll build a server which also runs some server-side logic, something the development servers of course don't do. They just serve our local files. Now to get started with that, we need to create a server, and for that on the HTTP method we can call create server. The create server method does just what it sounds like, and it requires one important argument for that, a request listener. This is a function which in the end triggers for every incoming request. This request listener function takes two arguments which are passed in automatically by Node.js, and that's a request object and a response object. So this will basically be passed in by Node.js and will reflect the request which was coming in, so the headers which are part of the request, the data which might be part of the request, and so on. And this response object is also given to you by Node.js. It's an object which you can then use to configure the response you want to send back and to then ultimately send it back. So inside here of create server, we can now work with these two pieces to read data from the incoming request and to send back a response. And to start, very simple, let's start with the response object to right now do nothing with the incoming request, but to just send back a response. And there we can call write to write some data to the response. For example, a simple string where we say hello there. And then we can call end, which will send the response. So end basically tells Node.js we're done adding data to the response. You can now close it and send it back. And this is a very, very, very simple web server we could build with Node.js. Now, with the server created, we need to do one more thing though. We need to call listen on it. So we either chain this here, or we take the extra step of storing this in a separate constant, and then we call listen on this constant, so on the object, on the server object stored in the constant. Listen is required to then actually start the server. You can think of create server as a method to build the server, but then listen starts it up and listens to incoming requests. Listen also takes the port on which you want to listen, and here I'll go for 3000 for my local development only to use this special port locally here. With that, if we now save this, we can again run our app.js file, which now holds the server, and you will notice something interesting. If I do that, we don't get an error, but we also don't complete this process. My cursor here in the terminal is stuck. Now you can always quit this by hitting Ctrl+C, but it is stuck for a good reason. It is stuck because this is an ongoing process. This script now doesn't finish once all the lines have been parsed. Instead, listen in the end sets up an ongoing event listener, you could say, behind the scenes, which waits for incoming requests. And as long as Node.js notices ongoing event listeners, it does not shut down script execution, which is why this script execution is still going on, because we have ongoing event listeners. And that's of course what you want. You want your server to keep on running and not to quit after it was configured, right? So now we get this ongoing server, and to see it in action, all we have to do is we have to visit localhost 3000, and there you should see hello there on this page. You see hello there because that's of course the data we are sending back in a simple response. It's not HTML data or anything like that, it's a simple text, but we see it here on our own Node.js server. And now we're back in the browser, but this is now not browser-side JavaScript. In the end, this is the result of server-side JavaScript, which spins up a server and sends back a response. Now, of course, we might be interested in sending back some HTML data, right? That would be great. Now, of course, we can do that. Here, when we write our response, we can use HTML. For example, we can write hello there like this and have our HTML tags there. Now, if we do so, there are two things. One, we must now quit the server and restart it because we changed the file. The ongoing process, of course, still is based on the old file when we executed the process. So when we change the file, we have to quit the server and restart it during development. And of course, also after you deployed your server, if you change something in code and you want that code to have an effect, you upload it onto your server and restart the server. So onto your cloud machine and restart that server that runs there. Now with that is done. But now you'll notice something else. If we reload, you see hello there actually is displayed correctly. But if we open the developer tools and go to the network tab and you reload the page so that you see your request there and you access this, you will notice that under headers here, if you have a look at the response headers, so the headers that were part of the response sent back by the server, we say nothing about the kind of data that this actually is. Now, the browser here actually renders this correctly as HTML in the DOM. But this is not something we should take for granted. This is a smart guess by the browser here because it sees that our content seems to contain some HTML content. Not all browsers necessarily do that. Instead, it is a good practice and really important to set an extra header, so to add extra metadata to the response header when sending back the response that explains to the browser which kind of data is attached. Because this then tells the browser what to do with that data, and we're not relying on these smart guesses. Now, we worked with headers before, but there we worked with headers on the requests we sent from client-side JavaScript to a backend. So we set headers on the outgoing requests, something like the content type of the data we attach there. Now we need to do the same, but the other way around. We need to set headers not in the client-side JavaScript, but in the server-side JavaScript. And we can do that. On the response object, we got a set header method. This takes two arguments, where the first argument is the header identifier, and the second argument is the value for that header. And there, for example, we can set the content type. We worked with that before on client-side JavaScript. It also is a header we can set on the server side though. And set this to text/HTML. This is the standardized identifier for saying, hey, we got HTML text data attached to the outgoing response. So it's a text, it's a string, but it is HTML which is in the text. An alternative, by the way, would be text plain. And let me do that first to show you the difference. With text plain, we're saying this is normal text. Don't parse it as HTML. If we do that and we restart the server and we reload this page, you see now the tags here are output as text because the browser is not guessing, because we're telling it that the data we're getting here is of text plain, and therefore the browser is not guessing whether it should render it. Instead, it knows I should not render it as HTML because you're telling me it's plain text, and therefore it displays it just as a text node. We can, of course, now change this to HTML, restart the server, and now reload, and we're back to what we had before, but now in a cleaner way, because now we explicitly set this response header and tell the browser, hey, this is HTML content, please render it as such. And all browsers will then do that. So this is actually how we should send back our HTML code here. Now, sending back data is one thing. Typically, you also want to be able to receive data. Now, for that, we need to send back different HTML code. We need to send back HTML code which includes something that allows the user to send us a request. Now with that, I'm not talking about a script where we use the fetch API. We could do that, but it would be a lot of code we have to write here. We can instead start simple and send back a form. You might remember that a form had this default behavior that when a button was pressed, we actually had the browser default of a request being sent to the server that served the page, and we had to prevent this with JavaScript. Now here, I don't want to prevent it. I want to have this default behavior so that the request is sent to the server, because that's simply another way of building web applications. Instead of having client-side JavaScript do more of the work, we could take the more traditional approach with less client-side JavaScript, because we maybe don't need it here, we don't want to validate the user input here on the client side, and instead we let the browser do its default thing and send the request to the server, so that on the server we then validate the input and so on. Both is possible, and of course both can also be connected, as you will see later. So here we could render a simple form with the input of type text, like this, and with a button in there, and make sure you get these opening and closing tags right. Now in this button here, we could have a send text, and the type of the button, and that's important, should be of type submit. So now here I have a form element, then we have an input element, then we have a button, and then we have the closing form tag, of course. If we save that and we reload, now you see that here. Now if we enter something here and we hit send, you see the page reloads, right? You see that here in the network tab, this flickers because the page reloads. And you briefly see a second request, that's the outgoing request before the page reloads. Now the outgoing request by default is a GET request. On form we can set a method attribute and set this to post to send a post request instead. And we can set an action attribute and point at /nothing to tell the browser to which URL to send this HTTP request. And then to encode the data of the form properly, we should add a name attribute to the input and, for example, give this the username identifier. This is totally up to you though. With that, the browser is able to parse that form, have a look at all inputs that have a name, and basically create a data object behind the scenes where it stores the data entered here under a username key, and then sends a post request with that data object to this URL. That's what the browser now does, and that's a default browser behavior, has nothing to do with Node.js, nothing to do with JavaScript in general. We could just prevent this with client-side JavaScript, where we listen to the form submission and prevent the default, but I don't want to do that here. I want to use that default behavior instead. So now we'll send this request to the server. If I now reload here, and I enter something here and I hit send, well, we get the same behavior as before, but actually we will get a request here. We just have to parse it now. And for that here, let's work with that request object, which we haven't used thus far. Parsing the body of an incoming request can be a bit tricky or strange at first, but we'll later learn how we can do it in an easier way. We first of all start by creating a variable body, and that should be an array actually, because the body is received as chunks of data for efficiency reasons, and we have to basically store all these chunks and then convert them to text thereafter. So here we get our chunks of data. Now we need to extract the data from the request body actually. Now before we do that, let's see what's in the request. We could log the entire request object, but this will be a huge object. So instead I want to start by logging the method, which is one property we can read, and the URL. And then we at least see which requests reach this listener here, for which methods and which URLs. If we now save that and we restart this, and we reload here without sending that, we already see some output here, get and /?. The question mark was added earlier to my URL when I hit send here before configuring the form. If I remove that and hit enter here, we see just get /. So we see by default when we visit the page, the browser sends a GET request to our domain.com /nothing. That's what we get here. The rest of the URL simply is omitted here on the URL property. We just get the path on our server here. Now if I enter something here, however, for example, Anna, and I hit send, you see now we also got a post request to /nothing, which makes sense because that is what we configured here in the end. So this is now some data we can get there, but of course we want to get the body. And to parse that, we need to add a listener on the request, which we do with the on method. Not with add event listener, but with on. There is an add listener method, but that's not the right one here. We just want on. Now that's a difference to the browser because we're not working with a browser-side API here. And of course, generally, every API can implement this the way it wants. Node.js typically works with on or with once if we only want to listen once instead of with add event listener, but that's just something you have to get used to. So with on, we set up a listener here. And I want to set up a listener, first of all, to the data event here. This is one event Node.js knows, just as the browser knows click on a button, for example. Node.js knows the data event on the request. And here we need to provide a second argument, which is a function that should execute when this event occurs. There we will get our chunk of data, will be passed in by Node.js, and we can then add this to our array by pushing it into it. It's a normal JavaScript array with the normal JavaScript methods. By the way, on Node.js, you also have all these special methods like filter, map, and so on you learned about in the arrays module. This is supported in Node.js as well. So now on every data piece we read in, so every data piece that's coming in on the request, we add it to this body array. Now we're interested in the point of time when we're done receiving data. And for that, we can add another listener to the end event. This will be fired when we're done reading in the request, so when it has been fully parsed. There we also have a function that should execute in this case. And now we know the body array will be fully occupied now with our chunks of data. We will have all the chunks of data we got in this array. Now we just need to convert this body from an array of data chunks into some string data we can work with. For that, we can set body equal to buffer, which is a global object available in Node.js, .concat body, so body before we store it here is an array of chunks, to string. This is in the end just one way of converting this array of encoded chunks into a normal string and store that back in the body variable here. This is also why I use the variable here and not a constant. And once this is done, we know what's inside of the body. So let's console log body here then and see what is inside there. So if we now quit that server again and restart it, and we reload here and send Anna to the server, we now see this is what was extracted. Username equals Anna. Well, now we could parse this to do with it whatever we want. Since it's such a string, we could, for example, get the username by using body, split it on the equal sign, and then take the second element of the resulting array, which is the concrete username, so the thing after the equal sign, and then work with it. So now we could send back a response, and now it's important to send it back in the right place. Currently, what we're actually doing is we're sending back the response before we finished parsing the incoming request, because this here is asynchronous code. This listener here triggers multiple times potentially. This listener also triggers at some point of time in the future when we're done parsing this in. So these functions here, which we registered on these listeners, don't execute right when this line executes. They execute when this event happens. And that's the same as in the browser. The function you register on a click event only fires and runs when the click happens, not when JavaScript parses the add event listener line. So therefore, right now, what actually happens is this line and this line is executed, and then these lines are executed, and only thereafter, sometime in the future, these functions will execute. Of course, I only want to send back the response once I'm done parsing the data. So we should move this code actually in here, into this request on end listener, so that we don't send the response before we're done parsing this. So now if we save that, and we reload this, we'll see no difference, but this is technically cleaner. And it is not just cleaner, but absolutely required if we want to take that username into account in the response we send back. For example, if I add a h1 tag here, where I want to say hi username, then we should convert this to a template literal with backticks so that I can conveniently inject data here. And then we can say hi username here. Now, of course, to make sure that this also works before we submitted our form here, I will actually change username to let here and cut this code and set this to a default of unknown user, and then check if body is a thing, so if this is truthy, and set username equal to our split body here, only if that's the case, so that we have a fallback username here in case we haven't set one yet. And if we save that and restart our server, you need to hit enter here. Just reloading will not work. You need to hit enter here in the URL to send a new GET request. Otherwise, you just reload the past POST request. So let's hit enter here, and you should see hi unknown user. But as soon as you enter something here and click send, this will reload and show your data here. So this is then how you can parse incoming data and how you can send back a response. But obviously this is quite cumbersome, which is why we also have an easier or a better solution for that, and which is why we have a framework for Node.js, just as we have frameworks and libraries for client-side JavaScript code as well. Doing all of this data parsing and response generation code on our own is quite cumbersome and hard to scale. This already is quite unreadable here, and of course we could optimize this in certain ways, but it's certainly not how you would want to build bigger applications. Now, similar issues exist on client-side JavaScript though. There also, if you have very complex apps with a lot of access to your document where you create elements and insert elements, this can get cumbersome. Therefore, we also learned about React.js or other frameworks that help us with that. And we also learned that there are in general libraries that can make certain tasks easier. The same exists for Node.js. You can Google for Express.js to find one of the most popular Node.js libraries you can use. You can visit its page, expressjs.com, to learn more about it. And in the end, this is just a framework for Node.js, which makes building web applications, web servers with Node.js easier. We install it with npm, and in order to do that, we first of all need to turn this into an npm project here. So we can do that by running npm init here. npm is available since we installed Node.js, and you can just confirm all the defaults here. Once you did that, you have a package.json file, and now you can install new dependencies in this project. It's the same approach and idea as we had it on the client side when we managed our project there and enriched it by npm packages. The only difference is that now we will not need Webpack or any other tool to use that, because Node.js natively supports these packages and node modules, which is also why the folder is called node modules, as you will see. And we don't need Webpack or anything like that to combine all these files. That's one difference. We need it on the client side. We don't need it on the server side. So let's now install Express.js with npm install express-save, which will install it as a production dependency. And you see this new dependency entry here in package.json, and you see the node modules folder. And as I said, Node.js is natively capable of working with node modules. You don't need any extra tools to combine all these different files. With that, I will rename the file here to pure Node.js and add a new empty app.js file where we now can get started with Express.js and learn how we set up a web server with that, and how that makes it much easier to work with incoming data and also to send back responses, how to outsource our HTML code into separate files and not have it inline here, and how we can then build web applications with that. So let's get started with Express.js now that we installed it. And to get started in the app.js file, we simply start by importing it with that Node.js import syntax where we require Express and then store the imported package or the content of the package, the objects and functions exposed by the package in this constant here, which you can, of course, name however you want. Now, Express, or what you actually get in there, is a function. So what you can actually do here is you can simply create an app by calling Express like that, like a function. This gives you such a app object, which in the end is a object with a lot of features and functions provided by Express. So you set up Express by calling it like this, and then it gives you access to all its cool features on this app object, you could say. And one thing you can do on this app object is you can call listen again. And this, of course, might look familiar because we called listen on our pure Node implementation as well on the server. Now, Express and the app object, therefore, sets up this server for us behind the scenes. And that's really important. Express is simply a Node.js framework. It does kind of the same thing we did here. It calls create server for us, but it does so behind the scenes and then exposes this server on this app object together with a couple of other functionalities. So with that alone, we would have a running Node.js server powered by Node and Express, but this alone wouldn't do much. Now, what we also typically want to do is we want to act on certain incoming requests. And for that, it's important to understand how Express.js works. It's a middleware-driven framework. Now, that sounds very fancy. What does it mean? It means that in the end, Express is all about funneling the incoming request through a bunch of different functions which all receive the request and all can do something with it. And each function can either stop the request and send back a response, at which point the request will not reach any other function thereafter, any other middleware, or a function forwards the request to the next function, to the next middleware in line. So a middleware is really just a function that gets the request and then can do something with it. Now let me show you what I mean. We can register such a middleware by using the use method on the app object, and the use method takes a function as an argument. This is a function which Express will execute for us, and it is a function which will get the request object and the response object, and also an additional next thing, a next argument, to which I'll come back in a second. Now what we got here is basically the same request or a similar request as we got it here in the function we passed to create server, but enriched with some extra functionality. The same for the response. We got this response object so that we can work on the response we want to send back, and also that when we're done, we can send back a response. So what we could do here is, for example, we could set a header on the response. Let's say we want to set the content type, and we can do that in the same way we did it before in the pure Node.js example. And we set this to text HTML. Now that might be all we want to do in this middleware for whatever reason. Then we can add a new middleware simply thereafter, and the order does matter. This will execute first, then the request will reach this middleware. So here we again pass in a function where we get the request, the response, and this next thing. And in here, we could then decide that we're done setting up the response and getting data out of the request maybe, and we want to send the response to the client. We can do this with a special send method, which is new, which was added by Express.js, which does not exist in pure Node.js. And there we could send our h1 tag where we say hello world, just like this, for example, to have a very simple response. So we'll send back this string as our response data. We set the header on the response before, and this will be carried over into this function, so the different middlewares all work with the same request and the same response object, so to say. So what you set up here on the response also is applied to this response, but then here I sent the response. Now with it we got two middlewares, and now the only missing piece is we need to tell Express.js that from this middleware we don't want to stop the request. We also don't want to send a response yet. Instead, we want to forward the request after working on its response to the next middleware in line. And that's what we do with this next argument. This actually is a function we can execute like this. And all next does is it tells Express.js that we're not done yet, that instead it should move on to the next middleware in line and call that with the request, with the response, and also again with next, which we don't call in the second middleware though, because we're done with the response and the request here. We sent back a response, so we don't want to handle the request in any other middleware thereafter, because we already sent the response. What else would we do with the request, right? And that would be a very basic setup, which should render this to the screen. So if we now save this and we execute app.js again, you see again we got an ongoing process which we can quit with Ctrl+C, but which you of course shouldn't do as long as you're working with that server, as long as the server should be up and running. And now if we go back to our page and we reload this page, we see hello world, and if we inspect our request, we see on the response headers we have the content type. You also see there are more headers than before, simply because Express.js also adds a bunch of default headers anyway. So it automatically adds a bunch of headers, which we don't have to add on our own. So here we also see that Express.js is doing a little bit of extra work besides this basic node work we did manually before. And now we already have a bit of a more convenient way of handling incoming requests and sending back responses. but we're not extracting any data at this point. So that's something we might also want to do. And turns out this is also relatively easy with Express.js. To parse incoming data, again, we need some data. And I'll get that from the pure Node.js file. I will simply copy this response here with the backticks and replace my response here, this string, with that copied string. So that again, I try to output a username and I have a form here. Now, the username is not always set. So here I want to have a default username and then also get a body though, which allows me to get the username from that. Like this. However, actually we can remove the if block because we'll get the username out of the request body a bit differently. Instead of manually parsing the body like that, with Express.js, we can use a middleware that does this body parsing for us. So before we do anything with the response, we could have another middleware where in the function we execute there, we have all the body parsing logic so that in the subsequent middlewares, we get the parsed body available. We could write our own function for that, but thankfully there are third-party packages which can be integrated into this Express middleware flow that do that for us. And the very popular package for parsing the request body and adding it to the request object, so adding the parsed body to the request object, is the body-parser package. You can install this with npm install body parser --save to add an entry to package.json. And by hitting enter, this will now be installed and is made available in your project. Now we just have to import it here, body parser, by requiring body-parser. And now body parser, and that's the convenient thing, can simply be added here as a middleware. We just have to pick one of the parsing methods. For example, JSON if we had JSON data, or in our case here, URL encoded, which is essentially the form data we will receive. And if we do that, this package will add a default middleware, so it adds a function like this basically, to the Express middleware flow, where it parses and extracts the incoming body, the request body, and adds the parsed body back into the body field on the request object. So that now here we could say we want to set username, which now can be a constant, equal to request.body.username, because we gave our input here a name of username, so this will be the key by which we can access the field value, or unknown user, if that should be undefined for whatever reason. And now with that, let's give it a try. Let's restart our server by again running app.js again. And one fix we should apply here, because we get the warning here. We should add a options object to URL encoded and set extended to false there, which just controls how the body is parsed, and this default setting should be fine. So now we can start this without getting a warning. And now if we go into the URL again and hit enter here, don't reload, but hit enter in the URL, you see hi unknown user. And now if we enter, for example, Anna here, you see Anna here as output. And we do see that here because of that body parser package, which does that. So this is how we can parse the body with the help of this package and with the help of Express, which makes it possible to use this package. And that's, of course, more convenient than manually parsing the body like that. With that, we got a basic setup with Express.js, but now it would also be nice to not just send back HTML code like this inline in our JavaScript file, but maybe send back a separate HTML file or even a dynamic template file which renders HTML, but which also gives us dynamic injection points where we can inject dynamic content, because that's what we typically want to do. We want to prepare some content on the server and then create a HTML file which has some static elements that always are the same and some dynamic parts which depend on the data we generated on the server. And that's what we'll do next. So we want to create a full HTML page to the user. Now we can do that by creating a new folder maybe. Views is a typical name, but you can name it however you want, where you store all your HTML files you want to send back, though, will not actually create a HTML file in there, but instead a template which contains HTML content, but where we can also inject dynamic content so that we can have a mixture of HTML static content and dynamic content. This will be all then merged together into an HTML file on the server side and sent back to the client. So on the client, we will receive a HTML file, but it allows us to enrich this HTML file with dynamic content. And for that, we need a package, a library that allows us to define such a template, which then parses the template file and finds a special syntax in there, which we can use to output dynamic content, and that makes working with such a template easier. And for that, I'll install such a package, and that's the EJS package. Now, there are alternatives to that, and in my Node.js course, for example, I dive way deeper into that. But here we can use this EJS package, which is quite popular and quite straightforward to use. So here we can just npm install this package as an extra library. And now we need to tell Express.js, which supports such templating engines, as they are called, that we want to use this templating engine. And we do tell Express.js that we want to do that by calling the set method on the app object, which allows us to set up some global options. And there we want to set the view engine option with a white space between the two words to EJS, which tells Express that the engine for parsing our views, our templates, should be EJS, the package we just installed. And then we also tell Express.js where it finds our views. And for that, we add a views setting and point at the folder that holds our view files. And in my case, that's views, but if you named that folder differently, you would have to change it here. Now with that, we can add such a template here, and I'll add an index file in here with the extension EJS. This means that EJS, this package we just installed, will be able to detect this file and parse it. Now in there, you generally just write HTML code, as you're used to it. But you can add a special syntax, which the EJS package understands, to inject dynamic content. So let's generate a HTML file in here, and in VS Code, you can just type HTML, and pick this HTML5 option and hit enter, and it gives you a basic skeleton. Now here I'll just use Node.js demo as a title, and then here in the body, we can output the content we want to show, and it could be a h1 tag where I say hello, and then here I want to have something dynamic. I'll come back to that. And below that, I want to have my form. So I'll grab this code here from app.js and output that below the h1 tag and auto format it. So now we have this in a way more readable way. Now I want to output the username here dynamically, and for that we can use a special syntax which EJS, this package, understands. And you can of course learn all about the supported syntax features either in my Node.js course, where I cover this as well, or in the EJS documentation. Here I just want to use one of the most basic features with an angle bracket, and then a percentage sign, and then an equal sign and a closing angle bracket. And now between that, you can refer to any variable name which you plan on providing to this view. And I'll come back to how we provide that in a second. So here I'll point at user. You could use username here, really doesn't matter. I'll take user here. So now we have this special syntax in here. This is of course not regular HTML, but instead this is simply a syntax understood by the EJS package when it later parses this file. Now to tell EJS to parse this file, we need to make sure that we don't set back a response like this, but instead here, I want to render a view as a response. And for that, the response object has a render method, also added by Express.js. This does not exist in pure Node.js. The render method takes a couple of arguments, and the first argument is the name of the view you want to render. And in my case, that's index, because I have the index.js file in the views folder. You don't need to specify the path because we set the views folder to be the folder that holds our views up there. So now here, index, also no extension is required because we told Express that we use EJS, and that will automatically look for a .ejs extension. And therefore we can continue with the second argument, and that would be an object full of properties or full of data we want to provide to this template. And here we should provide a user property because that will be the data EJS then can use when it parses this template. So here I will set a user key and set this to username, so to this value. And with that, we got a setup where now we should render this file and have our dynamic content in there. So if we now save this and we restart our server and we go into our URL and hit enter here, I get an error, could not find matching closing tag. Yes, because here a little mistake. The closing tag also should start with a percentage sign. So it's closing tag percentage angle bracket. So just like the opening tag, but without the equal sign. So now with that, if we restart the server and we now hit enter here again, this looks good. And now if we enter something here, click send, we see that. So now this is working with the help of our template. Now, of course, you can render way more than just this single output there. You could have multiple such dynamic pieces as long as you provide all the data to the view here. And you can also do more complex tasks like loop through a list of data or render content conditionally. I covered that in my Node.js course, and the official EJS docs, which you find attached, of course, also are a great place to dive deeper. Important to understand is that if you inspect this in the browser, you of course get normal HTML code which is rendered here. Also in the response, if we have a look at that in the preview, in the response here, you see you get normal HTML code. We have no dynamic part here because this dynamic segment is filled on the server. On the server, we on the fly generate a HTML document which is then appended to the outgoing response. That's what the view engine does here. Now, this is a very basic Express.js application. Arguably not a very beautiful one either, but it shows us the basic idea behind Express.js and Node.js, and it gives you an idea of how you work with that, and that it is just JavaScript with new packages you can use, which you can't use in the browser, and with some new built-in modules like this file system module we used earlier, but in the end it's just JavaScript, just running in a different environment and therefore with a different purpose. Now here we're building a traditional web page, I'd say, where we render all the HTML pages on the server and we return them, and there's nothing wrong with that. Again, I can only point at my complete Node.js guide if you want to learn all about Node.js, because, well, that's a over 30-hour course. There are a lot of topics to cover when it comes to Node.js. So here we can, of course, only scratch the surface. Nonetheless, I want to dive into one other way of web application of backend of server side you could build with Node.js. Here we got a web application that renders HTML files on the server and sends them back to the client. Now, if you remember our practice app from earlier, what we did there, for example, is we got the location or the address or the coordinates for certain places on a map from Google's servers. We sent the request to Google's servers. Now, clearly what these servers sent us back was not HTML data, it was JSON data, which we parsed with this JSON method, if you remembered. And indeed, when sending requests from client-side JavaScript to some server, you typically exchange JSON data because on the client-side JavaScript, you might then have logic that edits the existing HTML page you're on, but you don't want to replace it entirely with some HTML code sent back by the server. You don't want to reload the entire page. You might want to tweak some parts of the page to give the user that highly reactive feeling. So therefore, this is a server which does not return HTML, as our server currently does here, but instead it returns JSON data. And we can, of course, build such a server too. And why don't we do that and connect it here with this little practice application by ensuring that when we create a place there, so when we create this share place link, we don't encode all that information here into the link, but instead we generate an ID for that place on the server side, store that in a database on the server side, and send that link back to the client-side code, so to this code. And then when a user visits this link, which includes that ID thereafter, and therefore the user ends up on this other index.html file and ends up in the myplace.js file, we parse that ID from the URL and again reach out to this backend server here to get the data, the address and the coordinates for that ID from our database, and then send this data back via JSON or as JSON to this client-side application so that there we can then render this. Why don't we do it like this? This would be a nice practice. And that's therefore exactly what we'll do next, so that we also explore this other way of, or this other kind of backend service we could build, also often known as a API or specifically a REST API, an interface we can talk to from any client we want as long as we send the correct data to the correct URL. To implement this new approach, we could delete the views folder, but we can also just ignore it. I will comment out these two lines because we won't send back any HTML rendered templates anymore. Instead, now I want to exchange JSON data. So for that, we can also comment out these middlewares here. And when we parse incoming data for our API, which we're now building, I also don't expect form data anymore, but I expect JSON data. So I will try to parse incoming JSON data here. Now I want to set up two routes, two URLs, which I handle here on this backend Node.js server. One URL, which can be triggered from share place. Basically, when we select a place here, I want to send a request to this backend server with the chosen address and the chosen coordinates, so that on the backend we can store that in a database and create a unique ID for that, which we then send back to the front end. And the second URL I want is reached from myplace.js, where we extract an ID from the URL and then request the data for that place here from our server as well. Now, to split our code a bit more and have a clearer structure, I'll create a new folder, routes, which should hold these routes, so that in app.js we just have the general setup, like this body parsing which I set up, and then we have our routes, so the specific different paths which we want to support, and the logic for that in a separate file. So for that, let's go into the routes folder, and here I will add my location.js file. You can name this however you want, of course, and there we also need to import Express by requiring Express. You need to import this in any file where you want to use it. Here I won't create a new Express app, so we'll not execute it like this. Instead, we can use another feature which is part of the Express package, and that's the Express router. We can execute this as a function here and store it in a constant. The router makes it easy for us to register different routes. You can simply specify the kind of HTTP method you want to support, for example, a post method, and then any incoming post request to the path, which you specify as the first argument, for example, /nothing or /add-location, whatever you want, will then be handled by the function you specify as a second argument, which receives a request, a response, and the next function here. So it's like a middleware, but filtered for a path and a specific HTTP method. And only incoming post requests to this address here will make it into this function. Now that's one of the two routes we need. The other route will be a get route because we want to get data. We want to get, let's say, a specific location for a specific ID. And I'll come back to how that works later. For now, let's focus on the post route. So here on the post route, the idea now is that we get some data, and keep in mind that we parse data here. So we got it already extracted and stored in this body property of the request object. And the data we get there are the coordinates and the address. And then we want to store that in a database. Now let's add the database later. For now here, I'll just use an in-memory storage, which will basically live as long as our server lives, but whenever we shut down the server, it will be lost. So it's not a great permanent storage, but here to get started, it's fine. And there I'll have my location storage, which simply is, let's say, a JavaScript object. And there I have my locations, which is an array. And now here, when we got an incoming request, I'll reach out to location storage.locations, and I push a new location in there. And this new location will receive an ID, which I want to generate on the fly. For that, we can, for example, use math random, which is not perfectly unique, but for now it will do. Later we'll have a better ID. And then I will have my address, which we get from the request body body.address, let's say. We expect an address field on the incoming request body. And the coordinates, which could be a nested object with a let key, which we get from request.body.let, let's say, and a lng key, which we get from request.body.lng. Of course, it will be our duty to make sure that when we send this request, we do provide this address field on the body of the request and this let and the lng fields on the request body. And with that, we should add this to our location storage. Now, sending back a response would also be nice, so that we basically provide some answer to the client who sent us this data. And here we can use the JSON method to send back a JSON response. It's like using send and setting the content type to JSON manually. Here we can simply abbreviate this and just send back JSON data. We can send back our object, which will be converted to JSON automatically by Express.js. And there we could have a message maybe where we say stored location or whatever you want to send back. You could also add extra validation where you first of all check whether you got valid coordinates and you maybe send back an error if that's not the case. But to not dive too deeply into that right now, let's ignore that and let's just assume we get valid data here. With all of that, we got our first route set up, but it lives in the location.js file. Right now, nowhere in this application, we tell JavaScript or Node or Express that we're interested in this file. So back to app.js, which is the file we actually will execute with Node, with this command here in the terminal. Here, we should import this location.js file, or the routes set up there to be precise, and we should then also tell Express.js that it should consider these routes when it funnels the request through all the middlewares. Now, to import something from that file, we first of all need to export something here. And here, Node.js has its own export syntax. You don't have an export keyword as you have it in client-side JavaScript. Instead, you export with module.exports. This, by the way, might look familiar to you. It is what we had here in the Webpack config earlier. Because I mentioned that this would be handled by Node.js, well, here is how we export something in a Node.js file. We then point at the something which should be exported, and here, that's the router with these registered routes that are added to it. So here we export this configured Express router, and now we can import it into another file. We do import with the syntax you see up there. We can import our routes here, however you want to name it, by requiring this file where we stored them. So /routes to go to the routes folder, and then location. Maybe name it location routes, therefore, but the name is up to you. Here we have a relative path. Before we just had the package names, but now we're not working with a package, but with one of our own files, and therefore we have to specify a relative path here. And also important, you can and should omit the file extension here. Node.js will add it for you automatically when it looks up this file. It will look for a JavaScript file in there after all. Now we just have to tell Express.js that it should consider these location routes, and for that, after parsing the body, but before you listen, you want to register a new middleware here, and that should just be the location routes here. Because turns out the Express router is actually a middleware you can register in your Express application. And now Express knows that it should funnel incoming requests through these routes as well. And there we have our filtering logic by HTTP method and by path to then execute these functions, which in the end are also just like middleware functions, you could say. So that was a lot of talking. Now if we start our server, let's see if it works. Server is running. Now we need to work on the client side and make sure that in share place, once we got coordinates and address, we send a request to our backend. Now the backend is running on port 3000. The frontend by default has port 8080. The Webpack dev server takes this. So we have no clash here. You have to use different ports because these are two totally different servers as if they were running on different domains. And therefore now here we can use fetch, for example, to send a request to HTTP localhost 3000 for now, because we're running this locally. But again, this is like a separate server. It is technically a separate server. And then here we want to send a request to /add location, because that's the path we're filtering out with a post request here. So send this to /add location, and now configure this request because, as I just said, it should be a post request. So we want to add the method here and set this to post and add a body to this request. And this body should be the coordinates and the address. So for that, we can call JSON stringify because we need to provide some JSON content here. And JSON stringify an object. And now it's important that we pass the right keys here. We have to pass the keys which we try to extract on the backend. There, we're looking for an address key, for a let key, and for a LNG key. So we should provide exactly these keys here as well. An address key, which holds the address we're getting here, and then a let key, which holds coordinates.latitude, and then a LNG key, which holds coordinates.lng. And this should now be a valid body for our request. Now let's also provide some headers here to tell the backend that we're sending some JSON data. So here I will add my headers. I will add the content-type header and set this to application/JSON to tell the backend that we're sending some JSON data so that body parser in app.js, which is watching for JSON data, knows that this is a request where it should parse its body. So now we're trying to send this. Then we get back a response here in the end. So we might want to parse that JSON data in there and return that. As you learned, this returns a new promise. And thereafter, we got the data in our response, which we for now can just log here on the client. You could, of course, also use async await if you wanted to. Here, I'll go for two then blocks. Now, in reality, you might also want to check if the status code is okay, if you got any errors. But on our server, we're not setting any other status codes than the default 200 code, and we're also not throwing any errors unless we have a bug in there. So for now, we can leave it as it is. It's just there so that we can have a look at how this generally works. So with all of that, let's save the client-side code. And then here, make sure you got all packages installed, which I'll do again here, because I deleted Node modules in this project in between the different videos. And with dependencies installed, let's run npm run build:dev to bring up that development server. Looking good. Running on localhost 8080, as you can see. So now here, if you visit localhost 8080, this works. Let's open a console to see if it really works. And now here, I will find a place, maybe also enter a correct one, 6th Avenue, find place. Now this works, but we got an error here, and it's coming from our server, and it's complaining about some course thing. Now what's that? CORS stands for Cross-Origin Resource Sharing. Now, the idea behind CORS is simple. You have some application, some website running on yourpage.com. For example, our Find a Place application where we see something on the screen and pick a location. And then we have another server, for example, our backend with these two routes we added, othersite.com, which you want to talk to from your first page. So we got these two applications. Maybe we built both of them, but they're running on different servers, as it is the case for us. One is running on localhost 3000, the other on localhost 8080, and these are technically two different servers. Now, we might want to exchange some resources. That could be a script, which we want to fetch from the other side. We can send a request and get it. But it could also be a request, which we want to send to the other side. And now, by default, browsers block such cross-origin requests. Only requests to the same origin, so to the same domain, are allowed. So on yourpage.com, we could only communicate with any routes that are registered on the same server, not on a different server. Now, this exists for a good reason, because by default, you of course want to protect resources. You shouldn't be able to fetch any data from any server. But in the modern web, where this setup of having standalone API servers is quite common, you of course want to be able to eject from this default. You want to tell the browser that this access is okay. So in our example here, on the backend, so on the Node.js server, and always on the backend when you have CORS issues, we have to set some extra headers that signal to the browser that this is fine, that this access is fine, that we're allowing this access from this other page. So we want to grant access to our post route and our get route, for example. And we do so by going to app.js and by adding some extra headers. We can add these headers here before we reach our routes where we do send the response, simply with a middleware function here where we get the request, get the response, and get this next function. And there on the response, we want to add a couple of headers. The headers we need to add there are access dash control dash allow dash origin. The value for that can be a star or the URL from which you want to allow access. So we could also specify localhost 3000 there, but I'll add a star, which means any other server can send me a request. We also should add another header here, allow methods. Here we can restrict the HTTP methods we want to support. And since I only have post and get routes, which I want to expose to the public, we can write post, get here. So if you send me a put request, you would still not be allowed access, but these two methods are allowed. And you can also add other headers to restrict the usage of your API, of your backend server here. Attached, you find a link where you can learn more about CORS and which headers you can set there. These two are all the headers we need, however. We thereafter should call next here so that the request is able to continue to our routes. And with that, we can save this and restart our backend server. Now back to the application. Let's try this again. You don't even need to reload this page. We can just clear the error here to see if we get a new one. Click Find Place again and still fail. Reason for that can be really tricky to understand, but for post requests, browsers actually also send another request first where they try to find out whether the post request is allowed. You can see this in the network tab actually. Here, this add location request has a method of options. We never send the options request here in our code, but the browser does this automatically for some HTTP methods, for example, for post requests. So on the server side, we need to allow options requests as well by simply adding this to the allowed methods. And now actually one more thing we should also do is add one extra header here, and that's the access-control-allow-headers option, where we define which headers the client might send to us, which special headers. And there I want to allow the content type header, because we're setting this in the client-side code as well. And now with that, we can restart this server, clear our errors here on the client, click Find Place again, and now it works, and we get back our success response there. So this is now how we can send a post request from a different server, from our client-side server, which has this static application, which has some client-side JavaScript running on it, to our Node.js backend application, which also uses JavaScript, but in the Node.js context, and which now communicates as a REST API with this client-side project. And that's quite a typical setup, actually. Now let's make sure the other route now also works. My goal is that users now actually get a link here, which does not include all this information, but just the ID which we generate on the server. And then we output this link here with the ID. And when we click the link or when we use the link, we reach that other route we defined here, this get route, to then load the data for that ID. Now, two things we need to do for that. For one, we should send back the ID to the client so that on the client we can encode it in the URL. So here I'll generate my ID here and store it in a constant and then refer to this ID constant here and also send it back maybe in a location or lock ID field here in our response. That's important. Otherwise, on the client, we can't generate a link with the ID in it. Then back to the client, we should take all this code, which disables the button and so on, into this then block so that this only happens once the data was sent to the server and we got a response. And now here from data, we need to get that ID, the location ID. We get this from data.logID. Why log ID? Well, because on the response, we're sending this log ID field. That's part of our JSON response. On the client, we're parsing this JSON data, so we get an object which will have this log ID field. And now the location ID should be part of that URL. So we replace this part here with log ID or location equals, and now we inject the location ID here, so that now the link contains the ID instead of the full address data. So with that, we should restart our server-side, server, so that we take our changes here into account, and then go to the running front-end application, maybe search for a 6th Avenue again, find that place, and now you see we got this link with our location ID here. Now let's make sure we also fetch that location by that ID with this URL, with this path on our backend server. So let's work on this URL here, or on this path. And here, we now want to retrieve the data for a given ID, because the idea is that on the front end, on my place.js, we now no longer parse the coordinates and the address from the URL params. Instead, on the query params, we will of course find such a location key, and that will hold the location ID which we want to look up on our backend server. So here we get our log ID by using query params get location. That's the key name we use there. And then we want to send a fetch request here to HTTP localhost 3000 in this case, /location. That's the path we're setting up here on the backend. So /location. And then here, I want to add this ID somehow to the URL. Now we could add a query parameter, but we actually can also add it as an extra path segment. We can add an extra slash here and then append log ID. Now we're sending a GET request to this URL where the ID is actually part of the URL. So this will be something like this URL and then some random ID thereafter. Now, then we'll get back some response, and just as before, we should return the parsed response, the JSON data, the parsed JSON data, and then we get the ultimate data in here in this second then block. It's then here where I want to create my new loaded place with that extracted data, and we'll have to see how we extract that as soon as we know what we sent back. Let's now go back to the backend though. There we will get a URL which contains the ID as part of the URL. Express.js is able to handle this. We can add an extra segment here to the path for which we filter, where we tell Express.js that we have a dynamic segment. So one which is not always the same value, but which changes. We do that by adding a colon here and then any identifier of your choice. For example, LID for location ID. But again, you can name this however you want. The colon is important though. Now this tells Express that we filter for GET requests to /location/something. And now in here, we can retrieve that location ID by going to request.params. There is a params object in there. Express.js provides this to you. And this will now have a lit key because I have lit up there. If you chose a different identifier here, you have to extract a different one down there. This will be the data which is part of the URL, this segment which is part of the URL. With that, we can now go to our location storage, which will not be cleared as long as we don't restart the server or we're running out of memory, to get our location by that ID. So in there, we have math random as ID, which is a number. What we get here will be a string, because whatever you encode in the URL will be a string. So we'll actually convert it to a number by adding a plus here. And then we can find this here in our locations array. So the location can be found by reaching out to location storage.locations. And then we can use the find method, which exists on arrays in Node.js just as it does on the client side. And here we learned how that works. This runs on every item in the array, so on every location. And I want to return true if we found the right location. So I want to return true if log.id is equal to location ID. Then I know I have the right location, and we store this here in this location object. Now, if location is falsy, and this also works just as on the client side because this is a default JavaScript features, this whole falsy, truthy, if check thing. So we can check for falsiness. If that's the case, then I actually want to send back a JSON response where I set my own status code with the status method here of 404. We can simply chain these two methods, and with that we first set a status code, and then we can add some extra data where we maybe add a message of not found. So with that we return an error response to the front end, and then we can do whatever we want with that information there. I just want to set this extra status code with the status method so that we have a chance to find out whether we succeeded or not on the front end. And I will return this so that we execute no code after this. Because after this if check, I want to run the code which we run if we found a location. And in this case, I want to send a response with the JSON method. We could add a status code here as well, but 200 is the status code, the default status code anyways, so we don't have to do that. And here, of course, I want to provide my location data. So we can set an address here by accessing location.address, because when we store a location here, we store an object which has an address field and a coords field. So we send back an address and then maybe coordinates, where we refer to location.coords. So to this coords field we're storing up there. And now this is sent back to the client. Now let's restart our Node server here. And on the client side, we now can also tweak this code a little bit. And to provide the coords to the loaded place, we can access data.coordinates, because we will send back a coordinates key here, which holds an object with let and lng, which is just what we need. So we access coordinates on the return data and data.address for the address. Now we might get a status code which is 404 if we have no place. So in this case here, I want to check if response.status is equal to 404, in which case I know we didn't find a location. And in that case, I want to throw a new error here where I say could not find location, and then add a catch block after the last then block where I catch any errors, like this one, where I simply show an alert with that error message to the user. Now with all of that, let's save that. And first of all, store a new place, because I restarted the Node server, so our old place will be lost for now. Find that place. And now let's share that place. Let's copy the URL and enter this here. And that looks pretty good to me. And it's coming from a server. And if we enter an invalid ID here, we get could not find a location. So that is working as it should with our basic REST API here, where we send requests to the backend and we handle them there with different routes for the moment to then just store them in our temporary memory storage here. Now, to come to an end, I now also want to add a little database to this whole thing so that we don't store the data just in our in-memory storage, which will be lost whenever we restart the server or when we're running out of memory and our server needs to free up some memory. Instead, I now want to use a real database. And of course, you can spend hours or a complete course on just databases. And indeed, I have a complete guide on MongoDB, which is a database, in case you're interested in that as well, besides my Node.js course. So definitely check out these two courses if you want to learn more about Node.js or MongoDB, which is a very popular database engine that works together with Node.js particularly well. And indeed, it's this MongoDB thing which we will try out now. You can visit mongodb.com to learn more about it and get started. And what we will use here is a cloud service they offer, so that we don't have to install and administer a local database, which is a lot of work. For that, you should sign in here or try free to create an account. It doesn't cost you anything. You just need to create an account here. And once you did create such an account and you did sign in, you will either end up on a screen like this or on a welcome screen where you can build your own new cluster. You can simply walk through all that cluster configuration then and pick the AWS option here. Pick something where you see free tier available so that it doesn't cost you anything to get started. Leave all the other default settings here, but double check down there for the cluster tier that you're going with one, which is free tier eligible. That would be this M0 sandbox, which I can't choose here because I already created a cluster based on that. You should be able to choose that. And then leave all the other settings, give it any name you want, and create that cluster. Now, I already did that here. I do have such a cluster here. And this is just a cluster for multiple databases you can add. Now, click on Connector after to learn how you can connect, and there on Connect your application. And there, this URL will become important later. Now, actually, before we do that, however, go to Database Access, and there you can create a new user with any password of your choice, which needs to have at least read and write access to your database. Also go to Network Access, and there, under IP whitelist, click on Add IP Address and make sure you add your local IP address. You should see this option here if you haven't added it already, as I did. So your local IP address should be added here. With that, you can go back to clusters, and now we can connect our application to this. The question, of course, is, how do we now use this URL here? How do we now connect to this database? And for that, you can search for Node.js MongoDB driver, and you should find this page here, where you can learn more about the MongoDB driver, which is simply a third-party package for Node.js that makes working with MongoDB and sending requests to it very easy. You just need to run this command here, npm install mongodb -save. So let's do that in our Node.js application, not on the front end. You won't communicate directly to the database from there. We do that from our backend. And with that done, we can start using that driver. Now, of course, you can learn all about the driver here in the documentation here. By clicking on reference here, for example, you can learn more about installing the driver and how to use it. And we're interested in the CRUD operations, which stands for create, read, update, and delete, because we want to add data, we want to read data. These are the two things we want to do here. Again, if you want to learn more about MongoDB and Node.js and how they work together, my Node.js course and my MongoDB course are great to dive in, because in both I cover MongoDB, and in both I also cover a bit of Node.js, of course, with the different focuses depending on the course title. Now here you see quite good examples though, for example, for how you add something to the database, and therefore we'll build up on that. It all starts by importing this Mongo client. So let's copy that code, go to our location.js file in the routes folder, and import this here. And then we want to perform such an insert operation when we get a new location. Now we need our connection URL, so we can copy that and set this up globally here in location.js as well, outside of our middleware functions. And this URL here, of course, should be the URL you find on your cluster. So you can just copy that URL and enter this here, and now replace username with the name of the user you created and the password as well. So in my case, I'm working with Maximilian as a user here, and I am using a password, which by the time you're watching this, of course, will have been changed already. Now in this connection string here, this /test thing, that's the database you want to connect to. And you can specify any name you want here. If it doesn't exist yet, it will be created on the fly, and I'll name it locations, and you leave the rest as it is. Now back to this CRUD operations description here. Now we need to create a Mongo client here based on this Mongo client we're importing. So we can just call client like this and pass in this connection URL. And then we need to call client connect, use this callback function which we pass to it, and inside of that callback function where we get access to the connected client, we can then use that client to run queries against it. So we can copy this here, this entire code, and move that into our post route here, using this client here with that callback function. Remove these assert statements, we don't need to do that here. You can remove the console logs here. We should leave that line here where we get access to the database which we connected to on this client. And then MongoDB works with so-called collections and documents. You have a collection, which is like a table of records, and you have a document, which is like a simple row in that table. So we have a collection here, which I'll name user locations, user-locations. And with insert one, you can insert one new document there. And the document I want to insert here should have the same format as what I inserted here in my local memory storage. We can comment out this code now, but I copied the object structure first. The one thing that differs is the ID. You don't need to add an ID field anymore. MongoDB will create an ID for you automatically. Now insert one does not just take this argument, it also takes a function which will fire as soon as it is done with this operation. This gives you either an error or the result of that operation. And here we can get rid of this other dummy code with insert many. We don't do that here. So we're good like that. We now just want to make sure that here in this function, which fires once we're done inserting this, we send back our response. So we grab this response code and only send this once this function executes, again for all this asynchronous code logic, where this will run at a later point of time, basically once this operation completed. Now theoretically we should also check for errors here and send back a different response if we got one, but to save some time here and not make this overly complicated, for now we'll just assume that this always works. Again, more detailed error handling and so on is covered in the dedicated courses. So now here we're storing this. The ID I want to send back has to be retrieved from that result we get here, however. So for that, let's console log R so that we see what's in there when we store something. And with that, let's restart our Node application here and let's give this a try. When we find a place here, that's generally looking good. Okay, now we got an error here. Now let's see what went wrong here on the back end by expanding this log. And we cannot read db of null is the problem here. Yeah, because db name here of course does not exist. I don't have such a variable. My db name is locations, so we should just enter locations here. I removed the db name constant from the example, or didn't add it to be precise. So we want to connect to the locations database, or use the locations database to which we connect here. And now with that changed, let's restart this backend server. Let's give this another try by again finding a new place here. And now this didn't throw a new error. If I clear the errors, we don't see a new error here. And indeed, here we get a success response. And this is the object we get back by MongoDB. Quite a complex object. In the end, what it will have, though, is an inserted ID property, which is just what we need here. So we send back here not ID, but r.inserted ID. That's what I want to send back to the client. And now we don't need to generate our own ID here anymore. And with that, if we now restart this, and we find a new place, now you see here, we got this ID, which is generated on the backend. So with that, we're storing data in MongoDB. Now retrieving it would also be nice when we send the GET request from this page, because right now, of course, we fail here because we have no logic to retrieve our data. But the MongoDB driver docs got us covered. Here, if we scroll down, we find more functions we can execute. For example, for updating and for deleting documents, but I want to find a document. So we want to have a look at the read methods here. And there, again, we have all the logic for connecting. In the end, what we can do here is we can just copy this code here from our add location route into this get route here after we retrieve the location ID, effectively replacing this code where we use the memory database. And I still want to connect to my client here, reach out to the database, and reach out to the user locations collection. But now, of course, I don't want to insert one. I want to find one document instead. And you still pass an object to find one, but here you specify the criteria for finding a document. And you can find a document by ID here. The ID is actually stored on an underscore ID field in MongoDB. So we can use underscore ID here and then use the extracted location ID, which no longer should be a number. So let's remove the plus here as a value. So now we will try to find a document where the ID is equal to that location ID as a string, which we retrieved from the URL. Now we have to pass a second argument to find one, which is this function which executes once this operation is done. We either get an error or we get the document which we were looking for. And here I expect to get the document. So when we return something here, I of course want to use this logic from before. I'll cut that code and add it here and check if we don't have a document for some reason, in which case I still return the not found error. But if we did find one, then I want to return a response where the address can be found on the document. There it is stored such that we have an address property and also get the coords from the document. And the rest should be able to stay as it is. So let's give it a try. Let's save that and rerun the server here. And now let's reload this place. And I still get could not find location. And the reason for that is something MongoDB specific. The ID of an element which is added to the database is not actually a string. It's a special data type MongoDB uses internally. It's an object ID, which is not a JavaScript data type, but a MongoDB specific one. Now, when you query for an ID here, you therefore have to look for such an object ID data type. You can do so by using that Mongo client. Thankfully, it's not too hard to do that, however. When we import our MongoDB package here, we can not just reach out to the Mongo client here. So let's restructure this a bit and import MongoDB here just from MongoDB and get the client then from MongoDB.client so that we can get other things out of MongoDB as well. Because the other things I'm interested in this case here is this object ID constructor. We can use MongoDB object ID here and call new in front of it because this actually is basically a class which you can construct. And to that, you pass your ID as a string. So in our case, location ID. And it will wrap this in its own data structure, which now can be used in that query. And with that change made, if we restart that server, we can go back here, reload this place, and we get this place here. And that's it. Now, this is by no means a finished server. We could do far more on this server. Improve error handling, add more scenarios, make this code more reusable, and not always create a new connection here. But this is just there to get you started with Node.js and even MongoDB, which is not directly related to JavaScript after all. And it's there to show you how JavaScript is able to run in different environments and how you generally have the same syntax, but still can do very different things with it. And that's therefore it for this module. As I mentioned multiple times, if you want to learn more about Node.js and or MongoDB, I got dedicated courses for that. In my Node.js course, for example, I also spend a lot of time on MongoDB, diving way deeper into it and showing you how you can connect it to Node.js in various different ways. And therefore, these are the resources you want to dive in if you want to learn more. This hopefully still gives you a great overview of what you can generally do there and how that works. So this is it with this module. We learned a lot about Node.js, that it uses regular JavaScript syntax, but adds its own APIs like the file system, its own packages we can use, and does of course not support the browser default APIs like the DOM or the browser storage because it doesn't run in the browser, but that instead we run JavaScript in a different environment, on our machine or on any machine where Node.js is installed. We can also not just use Node.js to run utility scripts like this one, we can use it to set up an HTTP server, either by doing everything on our own or by tapping into the rich ecosystem that exists around Node.js, where we have packages and frameworks like Express and other packages together with Express.js that allow us to focus on our core business logic and where we don't have to worry about parsing data and so on. And there you learned how you can set up a server which returns some server-side rendered HTML files, or how you can create a so-called REST API where you have various endpoints, various URLs you support on that server that do different tasks depending on the HTTP method path combination that reaches your server. You even learned how to store data in a database and get it from there. And with that, you should have a good idea of which problem Node.js solves, how it generally works, that it's just JavaScript in the end, but with a totally different purpose or giving you totally different options of what you can do with it. And therefore now you really have a broad overview of JavaScript and what you can do with it and where you can run it and what that means for your applications.